So just some clarification. There was a question last time about why the angles were negative, right? And it really just has to do with the definition and the way that we define this. I mean, normally when we define rotations, we're given some values and we want to rotate them into some coordinate frame, right? But in this case, we're given the values in the rotated coordinate frame, right? We know S1, S2, and S3. Those are our principal stresses and directions in the Earth, and we want to rotate them back into the geometric, or you might say we want to unrotate them, right? So we're given the rotated values, and we want to unrotate them, and therefore that's why all those negatives, that's why all the angles are negative, because we're sort of doing an unrotation, if you will, okay? And then once we're back in the geometric frame, we'll then do positive rotations onto fault planes and into wellbores, okay? So it's sort of an unrotation. So at the end of the last class, or during last class, you know, we developed all those sort of rotation matrices in isolation. So I called this R1, this was R2, and this was R3, okay? And then we said that the total rotation matrix that's going to take us from the principal stresses into the geographic frame is R3, R2, R1, okay? And let's just go ahead. I think I showed you the final result, but let's just go ahead and show where that comes from. So I'm going to just do it in Mathematica because I hate algebra. So So I'm gonna create a matrix R1, and the nice thing I like about Mathematica is I can sort of type the things in there just as you would see it on the page. Can use the Greek symbols and everything. And of course, I said all the angles were negative, right? So so you can see that R1 is exactly as I've drawn it here, okay? So I can get both of those up. Right. So R1, R1. Okay. I'm just going to put the other ones in. By the way, Mathematica does the simplification, and you see all that happens is it changes this. Whenever you have a negative angle, the cosines are the same, and it changes the sign of the sign. So I had, this is positive sine, this is sine minus alpha. So when I do sine minus alpha, that becomes negative sine alpha. So it just does the simplification. Do what? Right there, you mean? Why isn't there a negative sign? It's a typo in my notes here. You see it there? Minus sign, minus alpha. I should have a minus sign right there. Should be gamma. Okay, so there's the R3. All right, so then RG, R sub G, is equal to R3, R2, R1. So there's the result. So there's the result I gave you, and that's where it came from. This should be the same. So this is also in the book, in Zobac's book, but he doesn't show where it comes from. So this is where it comes from. So looks complicated, but it's just 3 rotations in isolation.